Yes, now we're doing geometric progression. We talked about arithmetic. We saw the two formulas. Let's do for geometric and let's see the formula. So the first one is, okay, so what is a geometric progression? Well, it is one where the terms are separated by a multiple. So let's say you have 2, then 4, then 8, then 16, then 32, then 64, then 128, Okay, keeps going. Now, if we say, let's find the common difference. Let's first find the common difference. Let's try to find what is 4 minus 2? It's 6. What is 8 minus 4? It is 4. What is 16? Oh, sorry. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. 64 minus this. You see, it keeps going. It's 32. Then this one is 64. So you can see that you can't subtract and say there's a common difference. It can't be an AP. Because the numbers here are changing, 2, 4, blah, blah, blah. So it's out. So that means once you see that it's not an AP, then it's automatically going to be a GP. Okay, because those are the ones you have. And how do we see a GP? So we say 4 divided by 2, we get 2. That is now R, which is going to be common ratio. Then you say 8 divided by 4, you get 2. Then 16 divided by 8, you get 2. Then 32 divided by 16, you get 2. 64 divided by 32, you get 2. 128 divided by 64, you get 2. So this is now a geometric progression with R of 2. So we can say R is equal to 4 over 2, which is 2. Okay? That is going to be your common ratio. So anyway, this is going to be what a geometric progression is. And we saw that the common ratio is going to be the forward minus divided by the one behind. And that is going to be how we get it. Now, in our geometric progression, we need to know two things, which is this R, which is the common ratio. Okay, so this R is called the common ratio. Okay, this is called the common ratio. And then we need to know A. So A is equal to T1, which is the first term of your progression. Okay, remember progression is also called sequence, but they loosely use the word series in the questions. And here is our nice geometric progression or geometric sequence. And we can meet some questions around it. So when we are doing questions, we need to know A and R, and then we can do the rest. So what is it? We need to be able to find the nth term, and then we need to be able to find the sum. So we start by the nth term, like we need to be able to find term number 20, term number 30, and what is it? What is the formula? Tn is AR to the power of n minus 1. This is going to be the formula for your geometric progression. Okay? The nth term, it is AR to the n minus 1. Okay? That is how we get it. AR to the n minus 1. Remember, this is for GP. For arithmetic progression, which you're going to put probably in a video at the end, it was A plus n minus 1 D. Okay? Don't forget them. You're going to have to know all of them by heart. So this is AR to the power n minus 1. Then we go to the sum. So sum, for geometric progression, we have 3 different scenarios with 3 different sums. And here is the sum. The sum is going to depend on your value of R. Okay, the first 2 are depending on your value of R. So here's what we say. The first one is if we have, so the sum is going to be equal to A is going to be there at the top. So we have A, then we have 1 minus R to the power of n over 1 minus R. So on the top, it will be R to the power of n. Here it will just be R. So what if you say 1 minus R to the n, here you just say also 1 minus R. Okay? And the A is always going to be there outside, right? So it will be A multiplying 1 minus R to the power of n. This, when you say 1 minus, so the value you put first is going to be the bigger one. So if we are saying 1 minus R, then that means that 1 is going to be bigger than R. Okay? If we say 1 minus R, it means 1 is the bigger one, because we don't want to say 1 minus R and get a negative value there. Okay? So this would mean that R is less than 1. 1 is bigger. This is what you do when R is less than 1. If R is bigger than 1, remember R less than 1 means your R is probably going to be a fraction. A fraction is less than 1. Okay, so this is going to be actually R just less than 1, not necessarily a fraction, but any R which is less than 1, which is going to be negative and whatever. When it's a fraction, we're going to show it's going to be the sum to infinity, but this one is just when R is less than 1 only. Then let's go to the second scenario. It is when you have R bigger than 1. When R is bigger than 1, it's still A outside, but now it is R to the n minus 1 instead of 1 minus R to the n. Okay, it is now R to the n minus 1 all over R minus 1. Okay, and this is when R is greater than 1. Okay, remember we said the bigger one is the one we always tend to write first. Then we're going to have one which we'll call sum to infinity. And sum to infinity happens when you have your R being a fraction, a positive fraction. Okay, it's going, or a negative fraction, but it will be a fraction, and that fraction is a normal one, not an improper fraction, not one like 7/4. No, 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 not that one. Please, not that one, but one like 4/7 or -4/7, such like this. Normal ones, not improper ones. When r is a value like that, then you're going to get sum to infinity. We call it the sum to infinity. Okay, which is the sum which goes all the way to the end. If you want to see the video on that, why we call it the sum to infinity, you can check one of the videos, you see them. And here we'll say, okay, the sum to infinity is just going to be a over 1 minus r. Why do we say 1 minus r? Because it will be less than 1, okay? But this r to the n minus 1 is no longer there, or 1 minus r to the n, this part is no longer there. So it's just a over 1 minus r, okay? A over 1 minus r. This is when r is from -1 to 1, which means it's a fraction, okay? If it's a fraction, a negative or a positive one, but a normal one, okay? So these are the situations, these are the three scenarios. If we want, let's just write them one more time before we bring it to an end. We said that the formula for our nth term is ar to the power of n minus 1. Okay, ar to the power of n minus 1. Then we said we have three sums, which is the normal sum. We can say the sum is going to be, let's do for when 1 is bigger. It is a multiplying 1 minus r to the n, okay, over 1 minus r. Here it is when 1 is bigger, so r is less than 1. The crocodile is eating 1, which means 1 is bigger. Then we are going to have the sum being equal to a outside. Then we have r to the n minus 1 over r minus 1. And this is when r is bigger than 1. Okay, this is when r is bigger than 1. Then lastly, we're going to have the sum being equal to a over 1 minus r. It is when r is from -1 to 1. Okay, -1 to 1. Okay, and here we have our values. Okay, this means it's a fraction. This is going to be our things, and here are the sums, and here are the formulas which we're going to use. Goodbye for now. Let's go and practice them in the next bunch of questions. Okay, goodbye.